So welcome to the Micromeritics ASAP 2020 instrument training, or as we like to call it here in the Zhou Group, the BET instruments. We have two of these instruments in our lab. The first one is the left instrument, as we call it, and the right instrument. They are both the exact same instrument. They have the exact same accuracies and pressure sensors in order to monitor the micropore range within these materials. The difference is this right instrument has something called the vapor adsorption analysis. So instead of only testing the gas adsorption, we also can test using this feature over here, the vapor adsorption analysis. So here we are with the computer. When you are running this instrument, we use this program right here, the ASAP 2020 Micromeritics program. In order to open, double click on the icon. The program will open up and windows will be open. In order to open the windows and show what the instrument is doing, we have two options. The first option is to make sample files and look at our sample files through this file button, or we can look at the instrument parameters and how the instrument is working through this Unit 1 file. So what I'm first going to show you is we go to Unit 1, Show Instrument Schematic. So what this is showing you is exactly what is happening in the instrument. All of the pressures, all of the valves, all of the gas inlets that we have, the vacuum that is being pumped down, the sample tube that is right here, the P0 tube, which is a reference pressure tube, as well as a temperature probe. So everything that is happening with the instrument is shown right here. We also have the same thing for the degas. We go to Unit 1, degas, show degas schematic. And then here, we see that there's the degas portion of this instrument. So I just showed you the schematics on the computer, and now I want to show you where those are talking about here on the instrument. So over here on the left, we have our two activation or degas ports. When we are talking about doing gas adsorption analysis, the two terms that are used are degas and activation, and they are synonymous with one another. What that means is we are removing all of the gas molecules and solvent molecules, or guest molecules, from within the pores of our metal organic framework, covalent organic framework, porous polymer network, zeolite, porous silica, any sort of porous material that we may be analyzing. And so by using these two ports, that is how we can remove, through heating and vacuum, remove the guest molecules from within the pores in order for, over here, the analysis portion of the instrument to be used. This is when we actually use the gas or vapor of interest and figure out the adsorption capacity of that material for that specific adsorbent, whether it's nitrogen, methane, hydrogen, hydrocarbons such as ethylene, propylene, things like that, or vapors, things such as water, benzene, acetone, ethanol, and a whole wide variety of different gases and vapors. So now that I showed you the instrument schematics that are pulled up here, the degas schematic and the analysis schematic is shown here, and where those are on the instrument, we can also go to Unit 1 and pull up the status. What is actually happening on the instrument? So we go to Unit 1, Show Status. What this does is it brings up what is actually happening on the instrument. For the analysis phase, we can see the stage is idle, I-D-L-E. That means nothing is happening on the instrument. If we come back up here to Unit 1 again, we can see that if we go to degas, Unit 1, degas, show status. Here on show status, we can see the same thing that is shown here, but it's much larger and much more clear. We can see on the sample sample degas port number 1, it is idle, nothing is happening. But on sample port number 2, we have a sample that is running. So what it's shown here, as we just said, there is nothing happening on degas port 1, the left port, and there is something activating on port 2, the right port, okay? So after you see what is happening on the instrument, now we want to create a sample file. So we will go to File, Open, Sample Information. When we go to Sample Information, we will be in someone's folder. Right now, we are in one of our students' folder, and in order to go back to all of our students' folders, where every student or postdoc has their own folder, we can double-click these two buttons right here. we double click it, and we go back and we see all of the folders that exist for all of our students and postdocs. What we want to do, in order to open a folder, we can double click on that folder, and if we again want to go backwards, we just double click on the double dots, okay? So we're going to go into a folder here, we're going to scroll all the way down and all the way up and see all the files that are created, but we want to create a new sample file. So do not select anything. Nothing should be selected, and you just hit OK. Then it says down here in this box, open sample file information. It gives you some jargon about the instrument, where we are, what folders, whose folder it is, and what the sample name would be. But it says it does not exist, which is true. Do we wish to create it? And the answer is yes. We want to create a new sample. So we hit yes, and we bring up this sample folder, or this sample file options, where there are a bunch of different tabs for sample information, sample tube, Degas conditions, analysis conditions, adsorptive properties, and report options. And we will input information for all of them. So after we create the sample file, we want to come over to our balance with an empty, clean tube. There are two portions to the tube. The analysis tube, the BET or ASAP 2020 sample tube, and the top. The thing I want to get clear is the tubes are sort of inexpensive. They are replaceable. But the tops are very expensive and sort of irreplaceable. So if a tube breaks, do not throw away the top. Keep the top. It can be reused for other sample tubes. Like I said, the top is very expensive, and you do not ever want to throw away the sample top. In order to prepare a sample, we first need to get the weight of the empty tube. With all of these adsorptions, gas adsorption and vapor adsorption, these are per gram or mass-based metrics. So what that means is we need to know the exact amount of sample that we are using. We do that through a subtraction method. We first will get the weight of the empty, dry, clean tube, and then after activation, we will get the weight of the tube with the activated sample in it. We will subtract the two, and then we will get the weight of our sample mass. So in order to get this very accurately, as it is a per mass metric, we want to be very accurate with our mass calculations. When you come to the scale, you first want to zero the scale. Then you want to open the top, make sure it's reading 0.000, and then you want to put the sample tube on top of it, making sure that it is standing straight up and down and it is not leaning on any of the sides of the scale. So we have, in order to be accurate, like I said, we really need to be accurate with the mass calculations, as all of these adsorptive data sets are per mass calculations with these instruments. And so we want to take 3 measurements each time. So we can see, we let it level off, and we can see 37.8219 grams. That is our first mass measurement. We can open the side, take the tube out, hit 0 again, tear the scale, wait for it to go back to 0, and then get a second weight. And then we will do it a third time. We will take it off, we will hit 0. Again, we will wait for it to read all zeros on the scale. And then we will take the mass a third time. After we take the mass the third time, we will average all 3 masses together in order to get the actual mass of the sample tube. This is a way that we make sure we are as accurate as possible when getting the mass of the tube. Next thing that we do is to load the sample into the tube. In order to get the top off and put the top on, there's a very simple way. You don't want to just shove it on and press it as fast or as hard as you can. By pulling and twisting a little bit, you get the sample top off very simply. Or by pushing and twisting, it goes on very simply as well. So we're going to take the sample tube off, and then we're going to open our sample, and either using a spatula, whether it's metal, glass, plastic, or by putting our sample onto a piece of whey paper. We want to add our sample into the tube, and we want to add approximately 100 milligrams. 100 milligrams is the ideal amount, 0.100 grams is the ideal amount of sample that we should use for all of our measurements. That ensures not too long of time is used for each analysis, but we have enough sample that the error on the analysis is minimized. So it's best case, use 100 milligrams of sample. So what I will do is I will take a little bit of the sample, I will take it off, I will put it on a piece of weight paper, then I will take some of the weight paper and I will funnel it into the sample tube. There are all sorts of different ways that you can input sample into the tube, but you just need to make sure it comes to the bottom, that it does not stick on the sides of the tube, because then the analysis might have some error in it. So however you add it, 100 milligrams of sample approximately, and make sure it all gets to the bottom of the sample tube. Once we add approximately 100 milligrams of sample, we will then go ahead and close the sample tube and get ready to put our sample on the activation or degas port. So now that we loaded our sample, we want to come back to the computer and come to our sample file. You can change the name to whatever you want. Now, we are going to just go ahead and put training into the name. Now, there are two ways to enter the sample mass. I prefer to use the calculate, but you can also just enter the sample mass after if you calculate it yourself. But for right now, we're going to go ahead and use the calculate function, and we're going to input this empty tube sample mass that we just calculated from our 3 measurements of the empty tube. I'm going to make the sample plus tube 0 for the moment because we do not know that yet. Then we're going to skip over the sample tube because there is only one type of sample tube that we use in the group. And so all of these are constants for the type of sample tube that we use. Then we're going to come next to degas conditions. This is where we tell the instrument at what pressures, temperatures, and times we want to degas or activate the sample. Here in the replace button, if I click the replace button, we can see that there are a bunch of preset examples. Say 25 degrees for 10 hours, 60 degrees for 10 hours, 180 degrees for 10 hours, 200 degrees for 10 hours. I'm going to go ahead and select the 180 degrees for 10 hours. But what happens if we want something different? We can change the temperatures here as a target temperature and a hold temperature. For example, if I want 185 degrees Celsius, which is the actual temperature that I want for this activation, I would go ahead and type 185 degrees in here and 185 degrees in here. Now, right now, its holding time is 600 minutes or 10 hours. But I want 12 hours for this. So we're going to go ahead and put 720 minutes in for the hold time. And so this is where you change the temperature and the time. All of the other files or parameters really do not need to be changed. They should stay constant for what your sample file is. So after we set up the degas, we now want to come to analysis conditions. This is where we tell it what pressures and pressure ranges we want to use. For right now, for the training, we're just going to stick to the preset samples that we have. So you come to replace, and then you can look through all of our preset samples. Oxygen adsorptions, nitrogen adsorptions, hydrogen, carbon dioxide, methane, and argon. Those are the presets that we have in the instrument already, but I would like to say there are many, many others that can be done, and that will be given to you in a separate training on how to do that. But for right now, to measure the BET surface area, we would want to use the nitrogen at 77 Kelvin, and we want to select that file and hit OK. Nothing else needs to be changed within this parameter file or this analysis conditions file. Next, we want to come over to adsorptive properties. When we're calculating the adsorptive data points, when the computer and the programs are doing that, every gas has different constants. For example, its maximum manifold pressure, its density conversion factor, its hard sphere diameter, its molecular cross-sectional area, and its non-ideality factor. Every gas has different constants, and so you want to make sure that we have the constants that are for nitrogen. So we will go to, or the gas or vapor that you are choosing to use. So we will go to replace, again, look through all the presets that we have, and we will select the nitrogen at 77 Kelvin parameter file. Hit OK. Lastly, we will come to report options. Same thing, we want to go to replace and select the parameter file that we are using. In this case, again, we are using nitrogen at 77 Kelvin, and so therefore we will select that parameter file. We will hit OK. Now, we have set up the sample information, the degas conditions, the analysis conditions, the adsorptive properties, and the report options. And we are ready to hit save on our sample file and start the degas. So now I will hit save and close. So now we are ready to load our sample onto the instrument. What we want to do is load our sample onto degas port number 1, as that is the port that is not being used at the moment. If both ports are being unused, it does not matter which port you use. We have 3 pieces to the connection part of the instrument. We have the first piece, which is the large outer ring, and is what actually screws onto the instrument. That goes on first. Then we have this inner metallic ring. That goes on second. And then we have our plastic or rubber O-ring that then goes on third. And that fits tightly around the sample tube. After that, we will raise up the other 2 pieces of the connection and bring it over here to the port. When you're putting this on, you need to make sure that you insert the tube straight up and down, as there is a needle that is underneath here. And that needle is what pushes down on this sample tube cap in order to let air or gas in and out of the sample tube. So make sure you press the sample tube straight up and down and then screw on the sample tube, the connection. You want to make sure it is tight. You do not need to use a wrench or anything of that nature. You just want to make sure it's hand tight. But making sure it is tight is very important so that there are no leaks within the analysis or the activation of your sample. Finally, we want to take the heating mantle and secure it safely onto our sample tube. We want to make sure we do that without moving the sample tube left or right, and be very careful. So we will put the heating mantle straight up and down, and then use this little lock or holder that will be inserted onto the heating mantle to squeeze it around the sample, so that way it can remain in place. So the next thing that we want to do is now start our sample degas. So we made the sample in file, but everything we do with the instrument, whether it's viewing the schematics, viewing the statuses, viewing the instrument log, starting a sample degas, or starting a sample analysis, we do from within Unit 1. So we will select Unit 1 and go to Start Degas. As you can see, it'll pull up this new window right here. As we can see, port 2 is blurred out. We cannot use port 2 because it is already in use. So now we will go to port 1, which is the left port, the one that we put our sample on. We will go to Browse, and then we will find our sample. So if we are in this window where we're seeing every student and postdoctoral fellows folders, we will go and find our folder. We will open our folder by double-clicking it, and then we see our sample named Training. We will hit OK, we will select it, and then hit OK, and then it'll bring up our sample here. Then, in order to start the sample degas, we simply click Start. Now what you will see is things start to happen in the status bar. It says it is now evacuating the sample to 13 millibar. So it's going to use the metered vacuum, port 6 and this port right here, to slowly evacuate the sample tube. We can see the pressure dropping from 1000 millibar, which is the pressure in the room, slowly dropping to 13 millibar. Once it gets there, then we will see something else happen. So now it got below the 13 millibar and it opened D5, valve 5, or what I like to say is the full vacuum. It is now pulling a full vacuum on the sample, and it is fully evacuating the sample down to 29 microbar. As we can see, the pressure right here is 1197 microbar. This may take some time to get all the way down there, but you want to make sure that the sample pressure is continually decreasing until it will get to the 13 millibar. The other thing that I want to show you is during this whole process, we can see the temperature right here. It is increasing the temperature to our target temperature of the heating mantle as 185 degrees Celsius, as we specified in our degas, and it is currently at 44, and it will continue to heat until it reaches your target temperature, in this case 185 degrees Celsius. Okay, so now that the degas is ongoing and almost finished, I wanted to talk about the absolute do nots, what you should not do of the activation or degas process. This also involves me saying what you should do before running the sample. What you absolutely should do to preserve the life of the instrument is pre-dry your sample. This is required within the Zhou Group. you must pre-dry your sample in an oven or on your schlenk line with a vacuum before putting on your degas. This prevents a lot of solvent molecules, which are typically organic solvents, from getting up into the instrument and corroding or creating leaks within the instrument. So the first thing you absolutely must do is dry your sample in an oven or on your schlenk line for 24 hours before running your sample. This involves the do nots. Do not have a wet sample. Your sample should be completely dry and solvent-free, minus a few solvent molecules that are within their pores. The last solvents that you should use with your samples after the solvent exchange process are alcohols, methanol, ethanol, isopropanol. If the last solvent that you have is another organic solvent, such as acetone, hexane, chloroform, dichloromethane, things of that nature, you absolutely must dry your sample for 48 hours beforehand. We do not want any of that solvent to get up into the instrument and create leaks. The seals in the instrument are either plastic or rubber, which can be corroded or damaged with organic solvents of that nature. The last thing is never, ever, ever have your last solvent be dimethylformamide, dimethylacetamide, or dimethyl sulfoxide, DMSO, DMA, or DMF. None of those should ever be the last solvent that was in your sample. One, that is to protect the instrument from those very, very corrosive and powerful solvents. And two, you will likely lose porosity from that activation, as those solvents are high surface tension solvents. You do not want those as the last solvent that was in your sample before activation. I'm going to repeat again. You absolutely must dry your samples for either 24 hours or 48 hours before putting your sample on activation. This is an absolute must and a requirement within the Zhou Group in order to preserve the life of the instrument. The last thing is, you should not take your sample off of the instrument until it says idle, or that the sample file has been completed, and I will show you that in just a minute. The final thing is, do not skip steps. There is a skip button on the computer program, but you do not, under any circumstance, want to skip steps unless instructed by Micromeritics or by an experienced service technician. Dry your sample beforehand, no DMF, DMA, or DMSO as your last solvent, and do not skip steps unless instructed by a Micromeritics service technician. So, now that our degas is completed, you want to make sure that the instrument and the program is actually telling you it's completed. So, as we can tell, we have this box that pops up that says the degas on port 1, the degas is completed. And we also see that the sample status of degas port 1 is idle. That means we are in fact ready to take the sample off of the degas port in order to continue the analysis. So now that we have determined that the degas is completed from looking at the instrument, now we want to take the sample off of the port. So first, we will remove the metal clamp holder and then carefully remove the heating mantle, carefully by not making sure we bend the sample tube back and forth, making sure we remove the heating mantle straight up and down. Next, we want to unscrew, while maintaining a firm grasp on the sample tube, we want to unscrew the sample holder from the instrument. So we'll unscrew it and then remove by pulling all the way straight down. So unscrew and pull straight down, remembering that there is a needle up here and being careful not to bend that needle. Then we will take the O-ring and the two pieces off of the sample tube, and for safekeeping, so that way they don't get lost, we will screw them back onto the instrument so that way they can be stored there for future use. So now that we have our sample tube, as we had the weight of the empty tube, now in order to get the weight of the sample, we need to take the mass of the tube plus the sample, and we'll subtract the tube plus the sample and the empty tube in order to get just the mass of the sample. So, as we did before, we will make sure that the scale is zeroed and that the tube holder is centered on the scale. We will zero it, we will wait for the scale to go to 0, and we will carefully place the sample tube with the sample in it on top of the scale and take that mass. Then we will do that 2 more times and take the average in order to ensure an accurate mass of the sample. So the next thing we want to do is open back up our sample file. We're going to open our sample file by going to File, Open, Sample Information. Again, if we are not in our own folder, we will come to this screen, we will find our folder, and we will scroll until we find our sample, and in this case, labeled Training. We will open that, and right here in the Calculate Sample plus Tube, we will input our new mass. As you can see here, we have 145.4 milligrams, or 0.1454 grams. That is a little bit higher than the recommended 100 milligrams, or 0.1 grams, but that is okay. More sample is always better. The more sample you have, the lower the error. Before we close out and save our sample, we want to go back to the analysis conditions and double check and make sure that we have inputted the analysis conditions, the adsorptive properties, and the report options that we want. As we are doing a BET analysis in order to find a nitrogen at 77K analysis, in order to find the BET surface area of a material, as well as the porosity, potentially pore volume and pore sizes of the material, we want to use, as was said, nitrogen at 77 Kelvin. So we will check that here. That's what it says. We will check it in the adsorptive properties. It also says that. And then in the report options, it also says it there. Then we will hit Save and Close. So now we want to load our sample onto the analysis portion, or the instrument analysis port of the instrument. The first thing we need to do is input the isothermal jacket onto the sample tube. When we are dealing with low temperatures, any variations in low pressures and low temperatures, any variation in temperature can cause a variation in pressure. If there's a variation in pressure, that can lead to an increase of error within the sample analysis. So we use this isothermal ceramic jacket that goes onto the sample tube just like this. It slides just simply on and off, and you want to put it towards the bottom of the sample tube. And what this does is it much more evenly keeps the sample tube at the same temperature as the temperature bath that we are using. The next thing you want to do is connect the sample to the instrument. You will remove the sample connector, the 3-piece sample connector, from the instrument as it was put there after the previous use. You will input piece 1, you will put on piece 2, and then piece 3, the O-ring. You will slide it down just a little bit so it's at the edge of the sample tube, just below the sample cap. And as we did with the degas port, we will carefully insert the sample tube straight up and down into this port, and then screw on hand tightly the sample tube until it is hand tight and it stays there. Again, you just want to screw it on hand tight, not using a wrench or anything like that, but to make sure that there are no leaks. The next thing we want to do is take this tube, which is called the P0 tube. What this is a reference pressure tube that is used, comparing the pressure in the tube sometimes to the pressure that is in the sample tube. That allows us to get different information that the instrument uses to calculate pore sizes, pore volumes, BET surface areas, Langmuir surface areas, and other things like that. So we want to make sure that this tube is carefully placed as close to the sample tube as possible. With back here, there's a little screw. You want to make sure that that is screwed tight. Righty-tighty, lefty-loosey. So we will, again, hug this P0 tube as close to our sample tube as possible while tightening that sample tube. We will prepare our temperature bath, or our liquid bath. We are using 77 Kelvin, or liquid nitrogen temperature. So we will be filling our dewar with liquid nitrogen. So now that we have the proper PPE, or personal protection equipment, on, safety goggles, gloves, and a lab coat, we can now fill our dewar, or liquid containment vessel, with our liquid nitrogen. I would like to say that we must do this not over the instrument. There are a lot of electronics that are a part of the instrument, so you must fill the dewar on the ground or somewhere safe, not near the instrument. So what we will do is, from keeping a safe distance, we will slowly pour our liquid nitrogen into the dewar. Okay. So now that the liquid nitrogen dewar is full, we have put the liquid nitrogen dewar here on this stage. This is a elevator or a stage that will raise up and lower down depending on what part of the sample analysis we are on. It is very important to maintain a clear and item-free area underneath the elevator so that it can properly raise and lower at all times. The last part of setting up the sample on the instrument is using this thermal styrofoam top. What this does is it will eventually make a seal with the dewar and the sample. What you will see is there's an opening here in this styrofoam piece, and you will use that opening to push just onto the sample file or onto the sample tube, and it'll sit just like that. So now that our sample file is correctly created and our sample tube is correctly activated and put on the instrument properly, we can now go ahead and start the sample analysis. Before we do that, though, we want to make sure that the sample or the analysis port is in fact idle, that nothing is happening. So now we're going to come up here to Unit 1, Sample Analysis. And that's where we're going to click that, and it will bring up this new box where it brings us to where we last were in the sample parameter files or our file windows or our student folders. So again, if we are in our sample folder, then that is great. If we are not, we will scroll until we find our sample folder, we will double click it, and we will open it. We will select our sample that we want, as in this case the training sample, and we will click OK. And now it'll pull up all of the information that we have for our sample. The sample mass, the sample tube, the analysis conditions, the adsorptive properties, the report options, the temperature bath, the ambient temperature, the P0 pressure, all of these things that are set on the instrument and in the sample file. So we want to double check and make sure everything is okay, and now it looks like it is okay. From there, we will then hit start. Now that the sample is started, we can come and we can look at both the operation, which is this is where our data points will show up when it starts detecting data points. But right now it is running through the preliminary phases, and what you do not want to do again is do not skip or cancel any phases that it is going through. At this point, the sample is running, and you should come back periodically to check on the sample. If something goes wrong, then consult a proper technician or Micromeritics and about what went wrong, and try and fix that from there. But there should be nothing that goes wrong if the instrument is working perfectly. It should go through the preliminary phases and then get into this analysis phase of the sample information, and then go through a termination phase. What we'd like to do is stay here and watch the instrument and make sure that everything is working properly. When it's going through the preliminary phase, it goes through several steps of this, and all of them are very, very important. It will remove all of the gas from the manifold. As you can see, it is vacuuming out the manifold up here. Then it will fill it with nitrogen. Then it will evacuate the sample tube. It'll do some measurements in order to get the free space of the sample using helium. And then it'll move on to a full evacuation of the sample prior to sample analysis. When it gets into the sample analysis, then that is when you will see the specific dosings of the adsorbent of interest. In this case, it'll be nitrogen. Your data points will show up here, and then once it finishes all of the data points, then it'll go into the termination phase. In this termination phase, it will re-evacuate the sample, fill it with nitrogen, cool it or warm the sample, depending on what temperature is being used, and then end the sample collection. So you want to make sure during all of these phases that you are checking on it periodically to make sure everything is working properly. And if something does not work properly, please consult the manual books that are here in the top drawer of our desk or under our instrument. There's a lot of information is here, or please consult Micromeritics and a proper service technician if something is not working properly. So now that the sample is running, like I said, you want to come back and check on the sample periodically. In the early stages, maybe every 15 minutes, and in the analysis phase, maybe every several hours. Come back and make sure everything is working properly. Once the data is collected, then you would want to analyze the data either on the computer here using this Micromeritics software, or pull the data off using a flash drive or an external hard drive and analyze the data on the Micromeritics Microactive software. In order to have further trainings on this, please consult the senior level graduate students within the group or the postdoctoral fellows within the group, and they will show you as a new student how to analyze the data, how to determine the BET surface area, the Langmuir surface area, the pore volumes, the DFT pore sizes, the BJH pore sizes, all of the things that we might want to look at from nitrogen adsorption, or if we are looking at some other adsorbent, whether it's methane, hydrogen, CO2, or a vapor, such as acetone, benzene, ethanol, water, whatever we are analyzing on this instrument, referring back to the literature, referring back to our group knowledge and the senior students and postdoctoral fellows knowledge, a part of whether the data came out successful or something must be rerun or changed as far as the activation or the synthesis of the sample that you are running. Overall, these are really, really amazing instruments. We get a lot of really amazing data from these instruments about the pore sizes of the instruments, the surface areas, the porosities, and the ability of our different materials to absorb a large variety of analytes. There are a lot of things that can be done, and please consult some of the other videos that potentially will be made, or Micromeritics or our senior students on how to do those other functions. But what was shown today is how to run the basics of the instrument, how to degas the sample, and how to run an analysis of the sample in order to get the porosity and BET surface area of any sort of sample that you are running.